Good morning, guys. This is our last unit of the year. It's a small introduction into trigonometry. It's section 7.1. I'll have this video for you today, and then you have one worksheet to complete for me that's due Friday by midnight. And then next week we'll have just a small quiz on this. So the three main functions of trig that we're going to talk about are sine, cosine, and tangent. So these are functions that we can use to calculate the value of the sine of an angle, the cosine of an angle, or the tangent of an angle using sides of a right triangle. It has to be a right triangle that we're in. And the relationships are listed here for you. So the sine of an angle is the opposite side over the hypotenuse. The cosine of an angle is the adjacent side over the hypotenuse. The tangent of an angle is the opposite side over the adjacent side. So the first thing you want to make sure that you're comfortable with these is how to know which side is which. So your angle can be in any of three places in the triangle. So if your angle, which here is noted as theta, is in this lower left corner, then the way that you find the sides is you would pretend you were taking a walk away from the angle, and the first side that you run into when you walk away from that angle is called the opposite side. The side that kind of sits next to or adjacent to the angle is called the adjacent side. The side that's the easiest to find always is the hypotenuse, because as you find your right angle and walk away from that, the side that you hit is always the hypotenuse. So again, you take a look at where your angle is located. You walk directly away from that angle towards the side that you can see, and that's the opposite side. The side next to the angle is called adjacent, and always the side across from the right angle is the hypotenuse. So we have a mnemonic to help us remember what the relationships are, which you probably saw in geometry class at one point or another. Again, because we're online here at the end of the year, you don't really need to memorize any of these. Obviously, you'll have your notes for you. So this is SOHCAHTOA, and this is for the sine of an angle. We take the opposite side divided by the hypotenuse, just like you see up here. Sine equals opposite over hypotenuse. For the cosine of an angle, it's the adjacent over the hypotenuse. For the tangent of an angle, it's the opposite over the adjacent. So that's where those letters come from. Okay, so for this first set of problems, we'll be using SOHCAHTOA, and we're going to leave our angles our answers in fractional form. So your first couple problems on your homework sheet are just like this. So the first thing we want to do here is make sure we understand where these sides are. So let's do that first. So here's our angle down here in the lower left. If we walk away from the angle, this first side that we hit is going to be the opposite side. This side down here that sits next to the angle is the adjacent side. And then the side across from the 90-degree angle is always going to be your hypotenuse. So for this first problem, when we're looking for the sine of theta, we're going to do the opposite side, which is 8, over the hypotenuse, which is 17. And that's all you need to do for that problem, because 8 over 17 does not reduce into any other similar fraction. These are really pretty straightforward, as long as you have this somewhere in front of you so that you can remember what your relationships are. So for the next one, here's your angle up here in the top right. So we walk across from the angle, and this side over here is going to be your opposite side. The side next to the angle is your adjacent side, and the side across from the right angle is your hypotenuse. So as long as you have that kind of set, these are not too bad. So this time we want the cosine of the angle. So it says up here, cosine is adjacent over hypotenuse. Your adjacent side is root 5, and your hypotenuse is 3. And you just leave it just like that. We're not going to be putting these into a calculator at all. We just leave them as fractional amounts. Then next, we'll do the tangent problem. We walk away from this, and this is the opposite side. The side next to the angle is the adjacent side. The side across from the 90 degree is your hypotenuse. Tangent of theta is opposite over adjacent. So the opposite side is 6, the adjacent side is 8. Now this one we are going to reduce, and we're going to call it 3 over 4. So for that one we had to reduce it to 3 over 4. For the next one, here's our angle. So this 23 is going to be the opposite side. The side next to it is the adjacent, and the side opposite the 90 degree is the hypotenuse. So here we want the sine is opposite over hypotenuse. So the opposite side is 23, hypotenuse is 23 root 2. Okay, so this one's going to have a little extra work to it. These 23s are going to cancel. So we have 1 over root 2. But we know we can't leave that in the denominator, so we're going to multiply by root 2 over 2. So our final answer here is just going to be square root of 2 over 2. Sometimes you'll run into that because you do see a lot of square roots in these problems. Last two. Here's our angle. Here's the side opposite. The side adjacent. Oh, sorry. This is the side adjacent. My mistake. This is the hypotenuse, because it's across from the 90 degree angle. We want the cosine of theta, which is adjacent over hypotenuse. Here's our adjacent, it's 15, and hypotenuse is 25. And here we can reduce again. These are both divisible by 5, so our answer is going to be the cosine of theta equals 3/5. Last one, here's our angle. This is the side opposite, this is the side adjacent, and here's our hypotenuse. So we're doing tangent of theta, which is opposite over adjacent. Our opposite side is 3, adjacent side is 9. We can reduce that to 1/3. So that's how you're going to do your first set of problems on your homework sheet. Okay, the next few problems are just really calculator problems. We're just going to use our calculator for these and round to the nearest 10,000th, which means we're going to use 4 decimal places for these. And so you want to make sure before you start, whatever kind of calculator you have to find your mode button and make sure that you are in degrees, not radians, because all of our angles that we're putting in are in degrees. So mine's already set to degrees, so make sure if yours isn't, you just would arrow down, walk over to degrees, and hit your enter key, and then you can quit out of there. So for these, you literally are just putting into your calculator, you find your sine, cosine, and tangent buttons. The small blue calculators are similar. They also have these buttons on them. You just type in, for this first one, we want the cosine, and we're going to do the cosine of 120, close your parenthesis, and hit enter. So that one's nice and straightforward. It's just negative 0.5, so we don't need to worry about too many decimals there. I'm just going to do a couple of these with you. They're really very straightforward. And then this one I'll do also is the tangent. Now careful here, you have a negative angle. Don't use your subtraction symbol down here. Don't use this. You have to use your minus sign that's down here. You have to use this. So I'm going to do minus 125. You see it showing up there. Hit your parenthesis and enter. So we want 4 decimal places, so that's going to be 1.4281 as your answer. Those are really just calculator. Just make sure that you understand how to use that. Your biggest issue here is to make sure that your mode I'll put it in the notes here for you too, is in degrees, because if it's not, you'll get some crazy answers that are incorrect. Okay. Last couple of problems down here are using SOHCAHTOA again. We're going to round to the nearest tenth, which means 1 decimal place. And so for these, you have to decide which of these 3 trig functions you're using. So let's look at this first one. Our angle is down here in the bottom left. If we walk across from that, we have the opposite side. We also are looking for the hypotenuse. So when we have opposite and hypotenuse, we're going to use our sine function, because that's the function that uses opposite and hypotenuse. So we're going to make a little equation here that says the sine of 53 degrees equals the opposite over the hypotenuse. And that's how we're going to start that problem. Sine equals opposite over hypotenuse. So now we want to solve for x, so we're going to multiply both sides by x. So we have x times the sine of 53 degrees equals 3. And then we need to move this over here, so we're going to do that using division. So we have x equals 3 over the sine of 53 degrees. So our final answer there with our calculator, we're just going to say 3 divided by sine of 53. Close your parenthesis. And the answer you get is 3.756. We're going to round to 1 decimal place, so we're going to call that 3.8. And then we'll jump over to this one, number 12. So for 12, we have our angle, we walk across, we have the opposite side, and we also are looking for the adjacent. So this problem doesn't care about the hypotenuse at all. We care about opposite and adjacent. That means for us we're going to use our tangent function because it uses opposite and adjacent. So we're going to say the tangent of 48 degrees equals the opposite side, which is 5, over the adjacent, which is x. Walks it through a similar process like we just did. So these x's disappear. We're going to have x times the tangent of 48 over here on the left equals 5. Then we're going to divide both sides by tan of 48 to get our answer. So we're going to have 5 divided by the tangent of 48, close that parenthesis. We're going to round to 1 decimal place, so we're going to get 4.5. Last 2 problems. Here we have an angle, opposite and hypotenuse, so we're going to use the sine function again. So the sine of 27 degrees equals opposite, which is x, over hypotenuse, which is 9.1. This is easier than the one we did up above. We're just going to multiply both sides by 9.1. And so we're going to get 9.1 times the sine of 27 degrees on our calculator. 9.1 times the sine of 27 degrees. So we get 4.1 when we round to the nearest tenth. And then very last problem, we have adjacent and hypotenuse, so we're going to use the cosine here. Cosine of 24 degrees equals x over 9. So here we're going to do 9 times the cosine of 24. 9 times the cosine of 24, and we get 8.2. Okay, those are the 3 types of problems that you'll be working on for your assignment that is due this Friday. I will post these notes on Canvas for you as well. There's those last 2, and it's really just SOHCAHTOA. I'm not going to do office hours this week. I have not had anybody pop into those, so if you have any questions though, I'll be watching my email. Please reach out to me. Make sure you try those problems, and I will be back on with you next week with one final video and one final quiz. Take care, guys. Have a good week.